My mic on? Yep, good, cool. So I'm Steven Siciliano. I'm going to be here talking about Logic Apps.
I'm Ilya Gribnov. I am the principal engineer at Microsoft, and I'll talk about Logic Apps too.
Yeah. So just as a quick reminder, please be sure to submit your evaluations. It's very helpful for us to get feedback about what we can do better, so just as a reminder. So today what I'm going to talk about is I'll give a background of the story of integration inside of Azure. I'll give an overview of Azure App Service and what that means for Logic Apps. And then we have a couple demos planned as well. We're going to give you some background on the architecture of Logic Apps, how they work, kind of where they came from, and what you can do to use them more effectively. So integration inside of Azure. In March, just about a month ago, we released Azure App Service. So hopefully some of you have had a chance to hear about that, to see the talk. I think there's actually been a couple talks on Azure App Service. So I'm going to cover that very briefly. But the other things I want to call out is today we have API management also in the Azure portal, as well as BizTalk services. That GA'd last year, actually. And we are working very tightly with the community to really hear from you guys as to what the important things to invest in are. So I'll come back to this, but really we're trying to be feedback driven in our development. So we've reached out through newsletters, through blog posts, and we want to hear from you guys about what the most important things to work on are. Also at WPC, we'll be handing out awards to the best partner integration solutions. So stay tuned for that. So building apps inside of Microsoft Azure brings a lot of great capabilities that you wouldn't get from building an on-prem solution. So for Azure App Service, we want to give you ways to deliver applications at massive scale with tens of millions of concurrent users at a time. As well, we want to make it easy for you to deliver and rev your code very quickly and deliver updates into the running cloud. At the same time, we give you insights into exactly what's happening for all your applications. So all of these things would be a bit more difficult if you weren't running on Azure, but Azure brings this to you natively. Before the release of Azure App Service, we had these three services available to you: Azure Websites, Azure Mobile Services, and BizTalk Services. I'm going to spend just a couple minutes talking about BizTalk Services. Just by show of hands, how many of you are familiar with BizTalk? So I would say at least half. So that's good because BizTalk is, in many ways, the inspiration for Logic Apps, but it isn't a direct one-to-one translation. So we learned a lot of things with the BizTalk Services release that we did last year. For example, we validated that bringing integration into the cloud is actually a key scenario that you care about. As well, having hybrid solutions is also very important. But at the same time, we found that there were some key feature problems and gaps with BizTalk Services. So really what we're going to work on through Logic Apps is to solve these key feature gaps, and in many cases we have, as well as to bring new capabilities that would not have been possible with BizTalk historically. One of the biggest challenges with BizTalk is the learning curve. So if you come and you try to install BizTalk Server, that alone is going to be a pretty steep learning curve, much less actually using it. So this has been a key pain point, and what it really resulted in was a sort of wall when you tried to develop for BizTalk. You had to go through this, you had to kind of leap over it to even get anything done. And as a result, what we found was people were, instead of delivering very simple, easy-to-use BizTalk solutions, they were doing a lot of hacking. And the reason that they were doing hacking is because it's really easy to just write 100 lines of code and orchestrate a couple APIs to bring some things together. But this isn't really what you want to be doing with your time. You don't want to just write a couple lines of code, and then 5 weeks later, somebody's going to come back and have you add a little more to that code, and then somebody else is going to have to maintain it, and they'll rewrite it, and it just turns into kind of the snowball. So instead of actually using BizTalk, because it was so hard, you would end up writing this code yourself. that's where we want logic apps to come in. So instead of a learning curve like that red line, you'll instead see a learning curve more like this. So our goal is that you can very easily deliver integration solutions in Microsoft Azure by using logic apps. So it starts out very simple, and we'll go through some pretty simple demos here today. But if you need more power, if you need more additional capabilities, it does become a little more complex, but at a very gradual rate. It's not like there's this big cliff or wall that you have to jump over in order to understand how to use integration. Going hand in hand with this, our vision, our roadmap for logic apps is to democratize integration. That's a very key point, because we see there being a lot of developers out here. There's a lot of people here who did not raise their hands when they said they'd use BizTalk. That is who we want to be able to take advantage of logic in the cloud, because you guys that didn't raise your hands, you would never have even probably considered setting up a BizTalk server and using that in the cloud and running that. But with logic apps, it's very easy for you to get started and to be able to use Azure to run your business processes. So that's really what we're going to focus on. Now, another key point is that we see ourselves as trying to be a leader in the iPaaS space. So to spell out that acronym, that's Integration Platform as a Service. So that means we are going to host your logic for you. Rather than you having to spin up a server and deploy a WebF workflow into that server and maintain it and manage it yourself, instead, we will manage most everything for you on your behalf. And you will only have to worry about managing the code that you actually want to write yourself. The third point is we are working on creating a rich ecosystem where people can bring their solutions, deploy them into a gallery inside of Azure, and other people can take advantage of it. So with the various types of applications we have, API apps and logic apps, you will be able to submit them and take advantage of them, the ones that have been submitted by other people. So at the end of the day, we see this as a very exciting time for people who want to develop applications. The key for an application is connecting to your customers. So you need a way where you can empower your employees, both yourselves and other people in your organizations, to be able to deliver these apps very quickly and in an agile manner at internet scale. So that's our vision for logic apps and more broadly for Azure App Service. So what we have done is we have brought together some of the key capabilities that already existed in Azure and added some new ones together for App Service. The 4 components for App Service are web apps, mobile apps, logic apps, and API apps. And hopefully some of you had a chance to attend All Up App Service talk. But in case you didn't, I'll just go through these briefly, and then we'll spend the rest of the talk talking about logic apps. But before I do that, I want to actually give a brief overview of some of the key new Azure capabilities that we've released in the last year that you may not be too familiar with. So the first one is I often get asked, do you have auditing inside of Azure? Do you actually track all the operations that happen? Can I go and see that? And the answer is yes to all of those. So any management operation that happens through Azure, through the Azure portal, through the API, through PowerShell, we actually track all of those. So you can come back later and you can see who has done what and when to your services as they're running. At the same time, you want to be able to have more granular control over the services that you've deployed. You may want one developer to be able to develop one particular solution, but not have access to the VMs that run your business's core processes. You can do that with role-based access control, which was also released last year. At the same time, you need to be able to manage the deployment lifecycle of your services. We do that with Azure Resource Manager. So for most of these, there are also other talks. Well, there have been other talks in Build. So definitely check those out if you'd like to learn more. As well, we have full management APIs. So all of the things that we show you today that you can do with logic apps, you can also do via REST API, which we fully documented, as well as through PowerShell commandlets that allow you to manage the creation and deletion of Azure resources. And finally, I get asked a lot about, will this be available on-prem? And the answer is yes. We work to take all of the capabilities that are available in Azure and bring that into each iteration of the Azure Pack. For those of you that aren't familiar with Azure Pack, it's basically imagine running a little mini Azure inside your own data center. So everything that you see today and in any of the other Azure talks will eventually be available inside Azure Pack. It isn't available quite yet, but over time we bring those capabilities down. It does lag a little bit behind because it's an on-prem service. We have to ship boxes as opposed to code. So Azure App Service, better together. It's one low price for all of these capabilities that we're going to talk about today. And we have a number of built-in connectors that you can take advantage of. So with Azure App Service, you will want to be able to build applications that take dependencies on other services out there. So for example, if you're a consumer-facing application, you may want to be able to talk to Twitter or Dropbox. If you're an enterprise-facing application, you may want to talk to DB2 or WebSphere, technologies that probably existed before I was born. So you can take advantage of all of these together through connectors. In addition, we have a number of protocol connectors that you can also take advantage of. If you want to be able to use FTP, SMTP, whenever a process kicks off in the cloud, we actually give you clean REST interfaces on top of those to be able to make those calls. So from App Service, we give you a bridge into any of these other worlds that have existed for a long time. You don't have to take all of your logic and move it all to the cloud all at once. That would be a very onerous task. If you want to do it, by all means, try. But in the meanwhile, if you don't want to, if you want to do it piecemeal, definitely you can take advantage of API connectors. Finally, on this slide, we have a number of BizTalk services that you can take advantage of. So our strategy for BizTalk specifically has been to break apart all of that giant monolith that you deploy that would take 3 days just to set up. We've actually broken it apart, decomposed it into a number of clean API surfaces that you can use individually. And it only requires you to install what you need. So instead of having to deploy this massive monolith, you can now take advantage of just, say, the extract functionality that BizTalk has for XPath, or just AS2 inside of BizTalk. So that's one of the key points there. Now, for the 4 app types, we have web apps, which allow you to deploy web interfaces directly into the cloud. And it supports a wide variety of applications. So everything that we talk about here supports these 5 languages. And it means that you don't have to use .NET. I assume since we're at Build, the vast majority of you love .NET. But if you don't, then you can definitely take advantage of other technologies as well. Now, mobile applications are great because they allow you to build a mobile backend for your web or for your mobile app. So if you want, for example, to be able to have a scenario where I can write a mobile app, and when something's done, I click a button, and it goes off into the cloud and does something. I'll show kind of a demo of that at the end. You can do that using mobile apps. The third piece is logic apps, which is what this talk is mostly going to be about. And that allows you to, without having to write code, execute business processes in the cloud. And finally, the API apps, which are those interfaces that I was talking about. These are the clean REST contracts that expose all the functionality that you need. So if you want to be able to have a connector to your own APIs, you can do that using an API app. And what's great about API apps is they have a consistent standard for how they describe themselves. So API apps use Swagger, which is an open source format. It's a metadata description format that describes all of the REST calls that an API has. And all the demos that we'll show you take advantage of this Swagger to be able to draw their UI appropriately. Finally, BizTalk V1, which is the BizTalk services, we've made a lot of improvements upon. So those key feature gaps I was talking about earlier, we think we've made a lot of progress on. So I don't expect you to read all of this right now. You can look at the slides later. But the point here is all of those red boxes, that was BizTalk V1. And with app services today, with both BizTalk and Logic Apps, we've turned a lot of those green. There's still a little work left to be done. If there wasn't, then I probably wouldn't have a job anymore. But we'll work on that. And based on your feedback, we'll take those improvements going forward. So before I jump into the demo, there's one more point I want to cover. And that is people have come to me and they've asked me, who do you expect to be able to use this? And the answer is anybody who uses Azure. So if you're a developer, if you're an IT pro, and you're familiar with Azure, you can come to the portal. Then you should be able to take advantage of Logic Apps to develop and deliver your business processes. But at this time, we are not targeting consumers. So we definitely don't expect my mom to go to the Azure portal and to write a simple process. That would be kind of crazy because the Azure portal requires you to have a subscription, and it requires you to see a bunch of stuff about VNets and VMs, and none of that stuff would really make sense, right? So we are thinking about this going forward, but for today, when we talk about Logic Apps, we're talking about the solution as a part of Azure that is focused on developers and IT pros. So now I can switch over to the demo, and if my computer hasn't completely gone to sleep. So what you're going to see here is this is the new Azure portal. Just out of curiosity, how many people have actually played with the new portal as this thing right here? Wow, most of you. That's great. So Logic Apps, as well as most of the app service capabilities, are only available in the new portal. So if you went to the full portal, you wouldn't be able to see that. But so yeah, so in order to create a Logic app, you can go to plus new down here. This gives you the create experience with a number of categories. All of app service is together in this unified place called Web and Mobile. And you can see here the web apps, mobile apps, Logic apps, and API apps. So you could create all of those here together. And when you create a Logic app, all you have to do is give it a name. So I'll just build Logic app. And you have to choose the app service plan. Now, the app service plan is very important because that represents the thing you're paying for. The plan is, you can kind of think of it as the virtual machine that all of your various apps can run on. And what's great about that is you can deploy as many apps as you want into the same plan without having to pay a cent more. So that's a great capability. And you can, of course, scale that independent of the app. So if you want 10 instances of this or 1 instance, you can do that in the portal here. But I'll just go ahead and click Create. And that'll go off and take a few seconds. So instead of using that one, I'll just go to a blank one that I pre-created. And this then loads up. This is the blade, as we call them, for Logic apps. And at the top of the blade, you can see we summarize the most important information about it. So you can see, for example, the name, its state, what its endpoint is. The endpoint is interesting because that allows you to invoke it from, say, a mobile application directly, as well as the plan. So this is the thing I'm paying for, and the number of runs it's had, et cetera. So I can just come here and click Edit, and this will open up the Portal Designer. So this is a simple experience that we've created to make it easy for you, without having to write code, to create a business process. Now, the first thing that you do inside a Logic app is you add a recurrence. So I can just click on that here. Sorry, I misspoke. So it isn't necessarily the first thing you have to do, because you can actually use many different types of triggers. So recurrence is just one type of trigger. But you could also, for example, trigger whenever you got a new tweet, or whenever somebody clicks a button in a mobile application. All of those are possible. But for this demo, I'll just use a recurrence. And I'll have this run, say, every minute. And I will actually click the buttons that I try to click on. So then I have created it so my Logic app will run based on this trigger. The next thing that you do is you add a series of actions into your application. So this gallery on the right-hand side here, this shows you all of the API apps that I've already provisioned into my resource group. These API apps could be ones that came from the gallery. In this case, Dropbox and Facebook, Office 365. These are ones that we've already published to the gallery that you can take advantage of yourself. But they also could be API apps that you create yourself that publish your own APIs from your organization. But I've added that on. So the first thing that I have to do when I add a card, or certain cards, is I have to authorize them. So this uses the standard OAuth flow, where it takes me to a Twitter web page, and I click Authorize, and that grants me a token from Twitter to be able to use the Twitter API. So now when I call Twitter from this workflow, it will act on behalf of my user identity. The next thing that you see here is a list of all of the actions that we've exposed as a part of the Twitter API app. And you can see I can hover over these guys and get details on exactly what these APIs are. And in fact, we give you a wide variety of APIs. We kind of show you the most important ones at the top, but you can see here here are all the other APIs that Twitter has, so I can get that information. But for the purposes of this demo, what we're actually going to do is we're going to search Twitter for tweets about Logic Apps and archive them to my Dropbox. So that way, I can come back later, and I can do a search on top of that, and I can see what people have been saying about Logic Apps. You can imagine you could very easily do this for your own company in just a few minutes. So when I click on an action, I see the input parameters to that particular action. Search tweets is a simple one because it just takes one field. So I'll just click Logic Apps. And so now this will go off and search for Logic Apps. So the next thing I'm going to do is I'll add a Dropbox connector. Just like the Twitter connector, this requires authorization with the Dropbox API. So it will show up a button. And once I click that, it will then show me again the list of actions that Dropbox has. So I'll just click that. And I already authorized that, so it didn't even ask me this time. Shows me a list of actions. And then for the action I want to do today, I'll upload a file. So this will upload the tweet content into my Dropbox. As with the tweet, I see the list of parameters to this Dropbox API. Now, this all is metadata driven. So we have not written a single line of custom UI to work with these APIs. Instead, these APIs all expose Swagger, which is that common REST metadata documentation format. And inside the Swagger, they contain all the information needed to draw this. So for example, the Dropbox Swagger says it has an operation called upload file. The upload file operation has parameters like file path, content, encoding, and whether or not to overwrite. And it even, the metadata comes from, this description comes from that metadata as well. So for the file path, I'll just type logicapps.txt. And for the content, now this is where really the power of Logic Apps comes in, is I can flow the data from the first step to the second one. Rather than having statically configure it, I can open this dropdown right here, and it shows me here are these outputs from that previous step. So you can see the Twitter connector outputs text, and it outputs the tweeted by, and so I can select them from here. So I'm just going to select tweet text, and that drops in a token, and we'll talk a bit more about the language in a little while. But for now, I'll just click Save, or I'll click the check mark, and then I will click Save. So now what's going to happen is this Logic app will run every minute. It will poll Twitter for any new tweets about Logic Apps, and then we'll upload them into a file called logicapps.txt in my Dropbox. So let's switch over to Dropbox, which I have in a tab, and see. So you can see here, 11 seconds ago, there was a new file called logicapps.txt added. And as you can see, somebody here probably tweeted about how excited they are about Logic Apps. So that's great. They haven't even seen the whole demo, and they're already excited. So I'll close this. So one of the things that you may have noticed is wrong with this flow, though, is this will actually only take one tweet at a time, which isn't very efficient. And in fact, because the file path is the same, it's just going to keep overriding that one file. So instead, what you can do is I can come in and I can edit this action again. And inside the action, I'm going to add what we call a repeat. So that will iterate over a list of things. So I can come back here and say repeat over a list. And into this field, I will pass this array from the previous step. So I can open this dropdown here. And this flows the body from this request into each iteration of this Dropbox connector. So instead of having a static file name, I'm going to have it be the ID of the tweet. So whenever you reference an item from that iteration, from the repeat, it's just a function called repeat item. And then I'll do tweet ID. In addition, I can append things to the beginning or the end of this field. So for Dropbox, I want to actually put everything into a folder. So I'll just call this my folder. So I'm just constructing a path here, right? And then at the end of the path, I'll do .txt. So what this will actually do is it will put the tweets into a folder called my folder with the ID of the tweet being the file name. And then for the content, you can type these expressions. But instead, if I just want to be able to drop in say, the fields directly, I can do that. And you see, we've pre-populated it with the expression you need. So you don't necessarily need to learn all about these languages. You can just drop them directly into the fields here. And then you can also, of course, add other text here. So I have the tweet text, and I can say, was tweeted by, and then it has the person it was tweeted by. And I can change any of these other fields, and when I click OK, and then save, so there you go, successful. So now what's happened is this updated logic app has been deployed into the cloud. All I've done is I've just modified a few fields in the UI, and it's up there, it's running. So I'm going to close this out real quick and show you one other view. So this view right here, this shows you all of the times that this logic app has executed. So for example, at 12:54, it went off and it did something. So I can click this, and I can see all of the actions that it took. Along with each action, I can see the exact inputs and outputs of that call. In this case, let's look at what the Twitter connector returned. And I can see here that it will have returned, say, a list of tweets. So you can see here, I can see all of the tweets that people have had about logic apps. I'm pretty sure I saw my name here. Oh, look at that. And I can close this out. And if I go now to my Dropbox, hopefully by now, so you see my folder was added. And if I open this up, I will see the tweets that have recently come in about logic apps 38 seconds ago. And if I open up one of these, you see it has now both the tweet text as well as who tweeted it. So you can definitely combine as many different fields together as you want, and you can use this to construct a great business process. So, oh, something failed somewhere. We don't need to investigate that right now. So just to recap, what I've shown is how you can very easily build a business process in just a few minutes by using the UI in the portal. Now, the key concept here was that we are flowing data between each of these steps. And this creates what we call an implicit dependency. So that Dropbox step, when it executes, depends on the Twitter step successfully executing. And because you're using the Twitter data inside of the Dropbox step, it knows that the first Twitter must execute, finish, and then Dropbox must execute. However, if you prefer to wire up your dependencies explicitly, so you say, I want this to execute, then that, you can. And we give you an explicit syntax to do that. You can use depends on. Finally, you can build even more complex expressions, which Ilya will cover in his section of the demo, to do things like when something fails, do an action. The other concept that I covered was repeating. So this allowed us to execute as many times as there was an item in a list. It's a for each, right? And you can also imagine, we have a function called range that just returns back an array of numbers. So you could do just your old style for int I equals 0, et cetera, inside of a logic app as well. Finally, I didn't quite cover this, Ilya will as well, is we have conditions. And what's interesting about conditions is they allow you to either conditionally execute or not execute. So with that, I'll hand it over to Ilya, and he'll talk about the architecture of logic apps.
Hello, everyone. My name is Ilya, and I am Azure Resource Manager Architect and Logic Apps Architect. And you guys see a great demo of Logic Apps, right? So everything beautiful, nice UI. But what we build actually is available via REST API. We have a concept of a definition. You can actually serialize the entire workflow you build in UI and check in your source code and use it later. So I'm going to show all these details about language and about how I can use Visual Studio to actually consume it within your project. But let's step back a little bit and talk about the Azure Resource Manager. So Azure Resource Manager allows you to orchestrate deployment of various resources in the cloud. So you may actually saw Mark Rusinovich demo how easy it's to create 200 node cluster in less than 5 minutes. That's actually tip of the iceberg. We can actually create 100,000 of resources in 5 minutes as long as you have subscription capable this number of resources based on the quota enforcement. So we have this great engine, and we decide it will be cool to actually expose it to our customers and let them run their own business logic. So that's why we built this Logic Apps engine. And you can actually find that it's very similar to what we expose in Azure Resource Manager as well. So if you guys either use like templates or you try to use like REST API, that's something similar. And this is something we want actually you guys try as well. So it's same engine. We share most of the implementation. It is highly distributed, highly available. We try to do as best as possible, make sure there's no failures, and like deliver, for example, each action have certain guarantees. But it's not really exactly the same as the Azure Resource Manager. For example, the first thing we did, we extend the language to include more functions. So if you look in Azure Resource Manager functions, there's only 8 of them, and most of them about string manipulations. For Logic Apps, we add support for logical operations, for math operations. We add support for JSON transformation. So you can actually use this logic within your workflow definition in order to like pipe information across different actions, perform transformations, some logic, and then it's all in very declarative language. What we also did in Logic Apps engine, we let them speak natively with JSON REST endpoints. So we add various authentication mechanisms like basic auth, client certificate auth, auth. So if you have a JSON REST-based endpoint right now, most likely you can use it within the Logic Apps engine already without any modifications. And if you have like XML-based or maybe not very RESTful API, you can create an API connector which you can use in order to perform this little bit of like transformation or make it like RESTful, so you can immediately start consuming it within the Logic Apps. Logic Apps also have unique concept of the triggers. So if you look in Azure Resource Manager, all these deployments happening manually. You can go in UI and click the button, or you can use like PowerShell to submit a new template deployment. In Logic Apps, we introduce a concept of the triggers. Triggers can be very simple. It's just run this thing in every 15 seconds, or it can be complex as like reach certain endpoint, get the output, validate certain properties. For example, you can actually use Twitter connector, which Steven showed earlier, as a trigger. When I can reach a Twitter API, search for a tweets, find some negative tweet about my company using sentiment analysis. If it's crossed a threshold, then I can execute the rest of my workflow in order, for example, like customer support to reach out the person and provide the support. So what we try to do with this language is to make it as simple as possible and remove a barrier to enter and try it as well. This is the simplest actual logical app workflow definition. It is only 4 top-level properties you actually need to know. In fact, all of them are optional. You can have workflow without parameters, triggers, actions, or no output values at all, and it's perfectly valid workflow which is doing nothing. Let's talk about the individual fields in detail. So what's the parameters? So the idea is basically you have the workflow and it's execute certain steps. And what you actually want to repeat these steps based on your different like dev test environment, or you want to change some values based on a certain situation. That's why we have a parameter. So you keep your workflow static, and you can supply parameters file or like provide parameters in line in a way that you don't actually need to change your workflow definition. It's actually very useful if you can consider checking in your workflow definition to source control, and then you have separate files, for example, for your production or test environments. We also provide in like basic support of the parameters validation. We expose the concept of the type. We can validate it's like string, integer of an object. We also allow you to specify default value or list of allowed values. The next concept is the triggers, which I mentioned earlier. Triggers have a recurrence. They basically run every 15 seconds, 50 minutes, the way how you configure it. you can actually have multiple triggers within the same workflow definition, right? So for example, you may actually consider triggering a workflow if there is various factors actually need to trigger it. But they actually work independent. The another interesting concept is actually that the trigger is a stateful. So you can use the previous trigger execution in order to make a decision. So for example, let's say you have a trigger which fires every time new files show up on a Dropbox and you try to copy them to, for example, OneDrive. Trigger fire, you have a list of files, but unfortunately your workflow cannot transfer all files at once, so you have to do it one by one. So you can actually use a state within a trigger in order to save a list of files which you already processed, and you can actually make it fully stateful. Or another example could be like a timestamp. Let's say I process chunk of work up to 10 a.m. and next execution I will process from 10 a.m. to 11 a.m. So trigger is stateful. It's very critical for certain scenarios. Another thing we actually have on a trigger is the concept of conditions. Conditions act as a post condition. They basically will run after we perform an REST HTTP call in order to evaluate that the trigger should be fired or not. So for example, previously I mentioned how you can use a Twitter connector in order to reach out Twitter and download a tweet and see if there is anything negative about your company. You can actually use conditions in order to say, get triggers or get Twitter tweet, get a sentiment analysis, and then you can use a condition in order to compare how negative score looks like. If it's super bad, then you can use one flow, and it's semi-negative, then you can use another workflow. Next concept is actions, sorry about that. So actions is a set of steps which will be executed each time the workflow is triggering. Actions have dependencies. Order of execution is inferred by these dependencies, but if two actions don't have any dependencies, you can assume it's run in parallel. In this case, the LogicApps engines provide a best effort to execute your workflow as fast as possible, and in most cases, if your REST API is very fast, it can take up to a few seconds. Like triggers, actions have also conditions. But this is actually preconditions. They will be evaluated each time the action is about to execute in order to decide should this action execute or be skipped. I will show you in a demo how we can actually use it later in order to perform an action if something fails, right? So we don't necessarily want to execute action if something succeeds. We can actually use a condition in order to compensate or have an action which only ran with its previous step fail. Like triggers, actions also have a state. They're fully stateful. The state is unique for each individual workflow execution, and you can use this step to, for example, achieve like scenario like, I want to use Azure Resource Manager deployment. I want to wait when it's completed, and I want to send like text message to myself that know my deployment done. In this case, I will create a workflow. I will have two actions. The first action will initiate a process of a template deployment and deploy my resources in Azure. Then I will wait until it's completed by using this stateful mechanism. And the last step will be just send text message. I will actually show you how I can send text message later. Steven already mentioned each action have a concept of repeat items. We allow you to repeat action for a list of individual items like an array. But what's interesting that an action can be not just HTTP action. Action can be actually trigger another workflow. As a result, if you have a list of items and you have another workflow, you can actually combine these two concepts together in a very powerful thing when your parent workflow gets a list of items, and in each item will be processed for child workflow, and you can have separate definition files. You can check in them in source control and then use them independently. And the last thing is the template language expressions. You already saw some of the expressions in UI. We don't hide them. We actually allow them user to use. They're basically an extension of the like a JSON. So the basic format of the workflow definition is a JSON file, right? But we want to allow you to express certain transformations, certain conditions, certain expressions. So we add this concept of template language expressions. They basically they start with the symbol @ and you can also see in form of the string interpolations, right? So these little things allow you to perform like math or string manipulations. Just like in JavaScript, all these template language expressions look like functions with the parameters, and you can use dot or index in order to extract properties. So they think it's actually very simple. You can actually see a few examples on the screen. Now let me go back to the demo in Visual Studio. So let me tell you what's going to happen. So I have a simple website which is currently running in Azure. And I'm going to create a simple logic app which will perform the endpoint monitoring. It will basically try to ping my website every 15 seconds, validate if it's succeeded or failed. And if it failed, it will actually send me a text message. Because I always want to know that my website is healthy, and every time something wrong, I want to see the text, and I will take some action. So let me go back to screen.
It's here.
OK. So here's my website. It's very simple. ASP.NET website is nothing special. As a few steps I did, I already provisioned an API app in my resource group. I have a Twilio API app. It requires a little bit of configuration. That's why I did it up front. It basically allows me to send the text messages. So now if I go back to Visual Studio, here's the new instance of Visual Studio 2015 with the latest SDK. I can hit a new project, and you can find Azure Resource Manager template deployment option available on the Visual C# and the cloud. So let me hit OK. It will list me a few options which I can use in order to bootstrap my initial template. There is two options specific about Logic Apps. One is just Logic App, and one is Logic App with API app. For the purpose of this demo, I will use Logic Apps, but I encourage everyone to try the second option. It will allow you not only create a Logic App from Visual Studio, but also create an API app. So as we mentioned before, you can create an API to connect your non-RESTful JSON endpoint to something we can consider Logic App. So this actually project will show you how to create an API and combine them together. So let's hit on Logic App. Yes, this is a simple project. It's only have 4 files, and it's include Azure Resource Manager template. This is logicapp.json, and it's include OK. This is Azure Resource Manager template and include the parameter file, so you can have different parameters per environment. I will switch back to different instances of Visual Studio when I complete my applications, and then we can look at in details. So basically, this is same initial Logic Apps application. Azure Resource Manager template for Logic Apps. I extended to add an additional resource. So you can see I actually have a resource of a type gateway tokens. I need this resource in order to allow communication between Logic Apps and API apps. I create a token inside an API, and API app basically saying you can call me, and this token is just used to handshake to establish these connections. And then the second resource, my actual Logic App workflow, which will perform a ping on HTTP endpoint and then perform certain validations on the conditions in order to trigger the text message. So we can see it takes some Azure Resource Manager parameters, but you can also find that we have same definition I described earlier. It has a single parameter, gateway token, which is a secure string because we don't want to display it in UI, and we don't want to make sure that no one actually sees it. They have a simple trigger with a type recurrence, which fire every 15 seconds. What this means that whenever I publish this workflow, it will start executing and will start firing every 15 minutes, or 15 seconds, I'm sorry. And we have an actions, which we have 2 actions. one of its type HTTP, and I have get methods and the specified endpoint to ping. This will fire every time it performs the get, and it's complete, and save a result saying, is it succeeded or failed, and what's the response code we received from the website. And I have a Twilio app action, which will fire only if my previous step failed. This is actually interesting. I'm using this condition expression in order to tell I'm only interested in this step if this expression evaluated to true. The way how I construct it, I basically take my action HTTP ping, I take the status code from HTTP request, I compare it with OK, and I'm only interested in if it's not equals. What's interesting in workflow definition, I never tell that my action Twitter is dependent on action ping. What's the template actually what's the engine trying to is actually try to parse everything and understand, and by virtually the fact that I'm using the status code from previous action, it actually knows that this action must execute after. Now look on the input section. It includes some standard parameters for API app. I need to express a host. Host basically defines where is my API located, so I can construct like REST URI in order to call it. And some authentication part. We are using the gateway token, so we can communicate with it. I also tell him that I'm actually interested in a particular operation. So you saw in the UI that there is a list of operations available from the API app. So I'm saying I'm interested in send message. And here is my request parameters for a send message. I basically put some cell phone numbers, and I use in the body of a text message. So as you can also see, I'm using the string interpolation. So I'm actually curious what status code my website returned, because I may be interested in like if it's internal server error or it's like HTTP not found. So I can take different actions right away. So let me go back to portal and browse to my resource group. Okay. Here is my build demo resource. Let me try to. Okay. Here is my resource group. As you can see, I have 4 resources here. This is my Twilio app, which I provisioned previously. I also have a gateway which participates in communications and ensure everything's secure. I also have my logic app site ping, which is currently running and monitoring website, and I have website itself. Let's go check the logic app itself. Well, if it loads. Okay, so as you can see, we already have some history of executions. One is particularly running right now, but let's go back and check the previous ones. So as you can see, so far my HTTP action is succeeding, and my Twilio app step is always skipped because I say I don't want to send a text message if everything's successful. So let's go back and simulate a failure. I'm going to my website, and I'm going to stop it. So the minute I stop it, my HTTP request should not reach the website, and hopefully in 15 seconds I'll get text message. Okay.
Do you want to show?
Just to help a little bit, I can actually try to submit it right now. Okay. I keep getting the text messages, and it says that website ping failed, the status code is forbidden. Okay. And if you scroll to the history of the runs, I can actually see that my HTTP action failed and my Twilio action succeeded because I just get a text message. So what's interesting, as Steven mentioned, we actually keep entire history of the input and output request. You can actually click on the link and see, in order to ping, I use get method and particular request URI. And in output link, I can actually see what's happened. You see, my website is not available, and that's the status code I received. So to recap this, I just want to tell you that everything you see in the UI is currently exposed and available as a RESTful API. You can create your workflow. You can check into your source code. You can deploy it within your application as a part of the template resource manager deployment. And you can use all these great capabilities in very simple and declarative form, right? So you guys don't need to be an expert. We hope everyone familiar with JSON and JavaScript, and you can actually connect these two things together.
So I think, did you actually cover how to do the deployment?
Well, I can show it's one button.
Yeah, so basically to deploy, all you have to do is right-click, go deploy, and then choose the resource group, and then click deploy. So it's that easy from Visual Studio to just get it running. Cool. So we have one more demo. So this is a app that I made in Sienna, actually. And what this does is this is an invoice tracking app. So every time that I add a new invoice, let's say I want a Raspberry Pi, it goes and it will actually send a text message to my phone. So what's running back here, this is the actual, so you can see there's the text message. So this is the actual Logic app that's running up in the cloud. And I can, one of the key things there is, one, via a direct interaction in a mobile app, I was able to push to the workflow to make it run. But the other interesting thing here is I can modify this Logic app very easily. So I could come in and I could say, instead of just sending a text message, let's also do a Yammer post when an invoice is added. So I can come here and I can click on the post message action. And let's go and find that Yammer group. So that 5446506. 5446506. And I can, just as before, I can flow the data into this step. And in this case, I can flow the data not just from the previous step, but from any of the previous steps, right? And then I can click OK. And now what will happen is not only will the Logic app fire off a text message, but it will also add to Yammer. So I can just come here and I can add one more invoice. Whoops. And I want a new laptop as well. So there we go. So you can see the Raspberry Pi, that's been approved because I approved the text message. And there's the second text message that I got from my laptop. And if I go over to Yammer now, we'll be able to see there's the laptop that I typed 10 seconds ago from App Service Logic Apps. So without touching my mobile code that's been deployed to my application, I was able to update that business process. So I added more functionality to my application very easily by just doing what took 30 seconds in the Azure portal. The other interesting point here is this showed a human interaction. So from my phone, I was able to approve that text message, and then the second step continued. So you can use this for approval workflows, for example. So I'll switch back to the slides. So to just recap, Azure App Service is a combination of these four things. In addition, this week we announced App Service environments. And App Service environments are great because they give you a way to coalesce all of the different code that you have onto a compute cluster that basically you run and you own, but will be hosted by Azure. And that means that you can take that and you can attach it, for example, to your VNet. So if you have private APIs that you want to use inside your organization, but you still want to be able to take advantage of API apps and web apps and mobile apps, you can do that by using App Service environments. So you can check that out in the portal. You can get started. There's a free tier, so you can just play with it yourself as much as you want. And the point I want to close on before we move to Q&A, it looks like we still have 5 minutes, is we want to be very feedback driven. Historically, we would come through and we'd create some 3-year roadmap, and being Microsoft, sometimes some of those things wouldn't ever actually get done. But we're not going to do that this time. This time, we want to be very agile and move very quickly. So we want your feedback. We want to hear from you. There's a lot of channels that you can do that. You can go to forums. You can email me directly, ask for my business card. You can go to user voice. But we want to hear what features are most important to you and what things you need to accomplish your business scenarios in the cloud. And based on that, we will move quickly, and within a few weeks or months, we will get things delivered. For example, I was in London 2 weeks ago at the BizHawk Summit, and a customer asked for the ability to do date-time formatting for strings. So in just 2 weeks, we were able to add that functionality into the portal. So we want to very quickly iterate and deliver functionality to you. So here is our Twitter handles. You can go to tryappservice.com. And I think at this time, we'll open up for questions. There are 3 mics here, so if you could just walk up to the mic so that way the recording can pick up your voice, that'd be great.
So what you guys showed here is like a million times more than you can actually figure out just by using the actual portal. Like conditionals, it's not in the portal, right? There's no way to actually edit conditionals in the portal.
So
right now?
you can actually. So we hide a lot inside the gear.
Okay.
So yeah, you can go to the gear and you can click it and you can add a condition. That comes back to that we want kind of a more smooth learning curve. So if somebody doesn't care about conditionals, they don't have to worry about it. But you're right, it could be a bit more discoverable.
All right, and if I can, it's awesome that you'll be able to figure out the dependencies, and therefore there doesn't have to be declarative form of if this, then do that, and conditionals can help you stop going down one path or another and even do compensation. How are you going to visualize that? Because right now it's kind of like a pipeline.
Yep.
And I could have something all the way at the end that has something really to do or a dependency on something very much at the beginning. Like, are you guys working on different UI paradigms? 'Cause
Yes.
that was
Yes.
one of the great things about, I'm going to say it, Windows Workflow,
Yeah.
was that it was very visual, and therefore you could see kind of how things would flow for all of its faults.
Absolutely.
But I'd like to
Yeah,
see that.
yeah, absolutely. Yeah, we're definitely working on revving the UI. So what we have today is kind of as simple as it's going to get, and we'll come up with ways to make it a bit more powerful and more intuitively visualize what's going on.
Awesome.
But it's not there quite yet. It's a
Love
preview.
it. Thanks.
Yeah, could you elaborate on the API environments? I think that's what you were mentioning. It was
Oh,
it's
the
like
app
a
service
hybrid scenario,
environments?
but it wasn't. I needed more
Sure.
details. I couldn't.
Sure,
figure out what
sure.
you were saying.
So for details on app service environments, I think there was another session that covered that. But very briefly, basically what that means, so when you create an app service plan today without app service environments, you basically own that VM and you can deploy your code onto it. With app service environments, what you do is you own the whole hosted service. So you can attach it to a VNet, for example. So that way it can use, say if you have ExpressRoute set up to talk to your backend service, you can use that VNet. And you can also, you have more control over the scaling. So with app service environments, you can go up to far more numbers of instances. Because previously you could only go to like 10 in the portal, right? But since you own the whole hosted service, you can scale that out basically as big as a hosted service can get. So, yeah.
Cool. Thanks.
Yep.
Hi. So you showed earlier the JSON for a Logic app, right?
Yep.
And you had the HTTP status code that was
Yep.
returned back, and you said that was kind of something that the engine would kind of just give to
Yep.
you for free. So if you're editing your JSON though, how are you going to know that without generating it through the engine first?
We
Is there a
actually
way to get
we
that
actually
back?
expose a schema. So if you notice, like there is in actual workflow, I'm editing the Visual Studio. There is like $schema section. We publish schema for Logic apps. That's basically the standard way how you can actually tell people, like, if you have an action of a type HTTP, please expect like a property code. In fact, we actually have more property. We have like status, we have code, we have message, we have error message, and other stuff. But it may not be that obvious, but I think JSON schema is the model how we actually want to expose it.
I think the one point there is if you do have your own custom API that exposes things that are not part of our CAN schema, then you can, it sounds kind of silly, but you can just try it out. And we show you all the inputs and outputs so you can see exactly what your API has returned and reference that.
Also in UI for each API app, which is a button which allows you to download the entire Swagger. So if you're familiar with the Swagger, it's declarative JSON, not a JSON scheme, but some other JSON-based format. You can actually tell which API it supports, what parameters to expect, and what's the output values. This is how UI is built. It's basically dynamic. It's go extract this information and then just build the workflow definition on top of this.
Thank you.
Okay. Yeah.
It seemed like the conditionals were at task-based levels of success or failure happened. Can that come down to a data level so that you send good data one way, bad data another?
Yes. So basically what you can do, let's say you have an action and you have multiple dependencies, you can actually fire these dependencies, but in certain conditions. So you can say, this only fire if success, this only fire if some property equal 10, and this only fire if some property like less than 5. As a result, you don't fork on an action, you actually perform a join. As I mentioned, the conditional are preconditions. Right? So in workflow designer, you basically draw you some stuff and you say, this go this way, this go this way. In our definition, in your action, you decide what's your dependencies and when it's fired. So within an action, you make this decision. But you can have like 5 different actions and they all compensate for different stuff.
Yeah, it can be any runtime output that you have. You can reference anywhere in any input of any subsequent action, including the conditions.
Yes.
Okay. Thank you.
Yep.
Hello. So we're talking about logic apps. Is there an idea to adding the development side, staging, and then final production of the app? Like we're talking about conditions and testing and doing.
Yep.
So I don't want to really post a tweet about a product that I'm just doing. So like create an example.
Yeah, so for the development pipeline, with the inside Visual Studio, you see how he had the definition and he also had the parameter files. So the typical workflow is you'd have like one set of parameters for your dev environment, another set of parameters for your stage, and another for prod. And then maybe for your dev environment, it wouldn't actually be a valid Twitter token, for example.
Yes. Or
If
you can actually use parameter in the condition, say if it's dev environment, don't fire tweet.
Yeah.
That's it.
So, yeah, you can definitely do it that way.
So they'll have to add that logic into this to
No,
distinguish.
the Visual Studio actually already support, if you actually try to deploy there is a drop-down, you select the definition file, and you actually have a list of parameter files. Each parameter files can be specific to environment, and then you can restrict functionality based on these parameters.
Yeah.
Okay. But once it's published, it just goes to
Yes.
Yeah.
live.
Yeah.
Yeah, so it's always running, but you don't have to connect it to the actual prod APIs.
Yes. So yeah, that answered the question, but it's I guess it's difficult to test if it's really going to send a tweet, or if the content of the tweet is real, if I'm not really sending it.
You can probably add some dumb action and just pipe the output, and then you can expose all input outputs. You can easily see what's exactly what's sent, exactly what received. So if you replace your Twitter with something else like basic save JSON to like Dropbox, you can actually see exactly what you expect.
Great.
Thank you.
Cool. Thanks a lot, guys. Feel free to send us email, Twitter, reach out to us. Love to hear your feedback. Evaluate the session. So let us know how we did, what we can do to get better. That's important. Please. Thank you.
Thank you.